I'd like to request and invite on stage none other than Alan Sayler. Can we have a huge round of applause for him, please? He's going to present on the topic non-conventional pipe crossing methods.
Good afternoon, everybody. I know you want to get out of here. I'll try to make this as quick as I can. I'm slated for 27 minutes, I guess. So I just wanted to share about some crossing methods that are conventional to regular normal construction. We have people in here that have been using these methods on their projects. We have people that haven't used them before or don't know about them. So Raj asked me to share about non-conventional construction crossing methods for pipeline installation. So I've been doing this kind of work for many years, and really in the industry nothing's really changed on how these methods are done other than HDD and some of the other newer technologies that aren't really being used for slurry pipelines are being used. So I just want to go through this and give you an idea of what can be done and what you guys are already doing. First of all, I'm going to talk about just crossings in general and some of the requirements. So on a pipeline project, you can understand that depends on how long the pipeline actually is. It all depends on how many crossings there will be. And with all the problems you see on your projects in India and other places around the world, it can be impact your cost of your project and schedule based on the amount of crossings. So the main thing is to make sure that your crossings are put in safely because of the impact by traffic and other things for creek crossings, river crossings, things like that. So I'm just going to go through different types of methodology. So that's what I'm going to focus on for your understanding. So the reason non-conventional crossings really came into existence was because of the impacts to the environment and the soil. Different things have evolved with environmentalists. Things have changed drastically on how we install pipelines on crossings. Trenchless methods are less invasive compared to the old open cut crossings. But first of all, on any project, there's a lot of planning, right? So depending on what you're doing, first thing you want to do is investigate on desktop. And I discussed this a couple years ago about investigating your project, but you have to understand your crossings. You have to get a number or list of crossings. You have to understand what they require, whether they require permits, what kind of roads they are, what kind of load restrictions are on them. And the design is critical. And also to get out and do the survey of these crossings for elevations and profiles. And definitely the geotechnical information should be obtained before construction starts to understand what kind of problems you're going to have with construction installation. So the design and construction details are very critical. The understanding of what the contractor is going to be working with can be normalized in front-end planning during detailed engineering with geotechnical investigations and understanding water crossings, road crossings. So it's very imperative to understand your design requirements and the engineering requirements so you know how to design the pipeline. So the basic principles for like road crossings follow API 1102 and also analysis developed by the ASCE. So there's all kinds of road crossings, railroad crossings, and they'll depend on how you're going to cross them. And basically what it comes down to is what kind of permit you have to have. So a lot of railroads require permits with casing. Some highway crossings require permits. Your rural roads usually don't require permits unless there's a special reason that they're being used for. So external loads are a big issue for pipelines, and that's where sometimes casing has to be used. So during construction, you're going to definitely run across pipelines that are going to cross your railroads, river streams, utilities, major and minor roads. So it's really crucial to implement the correct methodology for crossing these with the minimum impact. So I mentioned earlier, depending on the length of your project, for instance, if you have a 100-kilometer pipeline, you may have 30 or 40 road crossings. You may have 10 to 100 stream crossings, wetland crossings, whatever. I'm sure that some of you have encountered more than that on your projects here in India. Railroad crossings are typically fewer, but they're still difficult. And classifications roads depend on how many lanes they are. And also footpaths. You have to keep in mind of footpaths that people use. Doesn't seem like a big deal, but in some countries it is a big deal. This just talks about roads, what type of roads and railroads that you're going to deal with. Different various railroads with 1 track, 2 tracks, depending on where it's at. But you guys will encounter these, and you want to be able to use the right methodology to cross them. So open cut trenching, this is what we used to do. Sometimes you can do it, just depends on the profile of the river crossing, but nowadays if you had a river crossing like this, it'd be very difficult to open cut that and to maintain the rehabilitation on it and make it stable for erosion purposes. So that's why most contractors, most engineering firms, most owner-operators would sooner directional drill this than to open cut it because of all the issues related to the restoration of the right-of-way. Also back then, geotechnical data wasn't that available, and so basically they would just blast it. If they run into rock, they just blast the river. And I'm sure there are some river profiles that you can still do this depending on the profile itself. So these are high impact issues for erosion, vegetation, water quality, and the infrastructure around it that leads to these crossings. Here's a good example of a open cut profile that I'm sure that they spent a lot of money restoring this. And also there's a section of pipe here with the side booms that's going to be carried in for an HDD. So there's a difference. You still have an impact. But this was a picture from Ambatovi. So to overcome that, the engineers and contractors have come up with HDD, horizontal directional drilling. Gives you a reduced surface, less disturbance, and it's actually the method that most companies are using now. Also directional boring machine, small footprint, This is usually used for road crossings and for railroads sometimes. Soil is a big consideration. Soil conditions for any year planning, like I mentioned before, geotechnical information should be investigated before even thinking about what kind of crossing to use, especially if you're going to have a river crossing where you have HDD, or even some of these board crossings for your roads. So proper planning and thoroughly evaluate the potential for environmental issues. Stream diversions, sediment control measures, restoration planning. These are all things that you have to look at as far as the impacts for any type of method you're going to use, but the HDD and the boring method are less impactful than open cut. So for pipeline crossings, railroad design, carrier pipe required, API 1102, case pipelines. Case pipeline is a pipeline installed inside a casing that crosses beneath a road or railroad. Case pipeline crossing is not as popular as uncased crossings due to the possible increase of corrosion. So I know there's a lot of case crossing in this world. I've worked on many pipelines that after a few years, if they weren't installed properly, the casing seals, they short out, and then you have a corrosion problem on your casing seals. So I'm not a fan of case crossings. I prefer slick bores without casing, but once again, it depends on your permit. So my advice to any engineers is try to design without casing if possible, because as an owner-operator, you have to maintain that system, and once that casing seal short out, then you have to shut the pipeline down after a few years because you know you have corrosion starting. Casing pipe, you don't want the overbore on casing pipe to be much bigger than the casing itself, otherwise the road's going to cave in or the railroad's going to cave in. So it's very critical on board crossings to make sure that you don't overbore the road crossing or railroad. I had a personal experience on a project probably in the 90s where we had a dual 25-mile pipeline in the same trench, and we came to a railroad that had a grade of about, I'd say, 3 to 4 meters high. And the contractor, I was gone for a week for a meeting, but I come back and they had finished it. And 2 days later, after I got back, I got a call from the right-of-way agent, said, oh, the railroad called and said that the ground is settling where the railroad bore was done. I said, how can that be? And sure enough, I went out there and I got on top of the railroad, and there's a hole this big, and you could look down and you could see the casing pipe. And what they did, the contractor did, is it was a combination of two things. It was a poor design by the engineering company. They should have never done a dual pipeline in one casing. They should have did separate and a smaller diameter casing. But they installed this bore, and while they're boring it, they actually were pushing just as fast as they were augering, and they basically pushed the dirt out, and it basically caved in. And so it was a major railroad, and it was shut down, and we had to repair it. But as a combination of the design, combination of the contractor not performing properly. So stresses is a big deal for pipeline crossings, which is evaluated by our engineers when they design this. And it depends on what's required. If a permit requires casing, that's what you got to do. The angle, crossing angle, API 1102, and crossing locations depends on where it's at. Try to locate a place where you have a good profile away from rocky terrain, and standing water if possible. This is just an example of the minimum burial depth according to API 1102. You got your borrowed ditches on each side, and that's where your minimum depth comes from. This is the requirements according to API 1102. Once again, the crossing angle, crossing location, and burial depth are very important when you're laying out these crossings for either a case crossing or a uncased crossing, railroad or road. So these are the kind of things that you should be doing in your upfront planning when you're in the basic design. Get out in the field and investigate every one of these and take an inventory and try to get a tally on which type of crossing they should be or you want them to be, and then engineering will figure out what's required for permitting. So these are the non-conventional crossing methods we discussed a little bit about, but this picture here is a crossing I came across here in India a while back, and this is basically a failure based on, I don't know what happened. I had nothing to do with it. I just saw it, and it's like I've never seen an HDD come out in the edge of the road, sticking up out of the ground. So I thought it was kind of unique. I'd never seen nothing like this done before. So it's just, once again, this is bad planning, bad engineering, and bad contractor evidently didn't have a clue what he was doing. So this is what you want to avoid. So the key points about non-conventional crossing methods or trenchless methods include horizontal directional drilling, microtunneling, pipe jacking, auger boring, or direct pipe. Some of these you'll never use. Direct pipe, most likely you'll never use, but there may be some day when you may want to use it. It may be one of your only options. Microtunneling, same thing, but your HDD and your auger boring is going to be your main crossing methods. Once again, they reduce the environmental impacts. Some photos of horizontal directional drilling setup and microtunneling. Pipe jacking, auger boring, or slick boring without casing, method where the pipe is pushed through the ground using hydrostatic pressure. Often can be used for small to large diameter pipelines, and this is something that a lot of you guys will be using. Auger boring with casing and horizontal directional drilling. I can just give some short definitions. You can read them. Moiling and direct pipe. Moiling, I'm not a big fan of moiling just for the fact that sometimes in the past we put it in our project specifications that we would not use moiling because of the impact it has on schedule. If the ground is sandy soil, you'll have problems. What happens is you will start hammering, vibrating, and if the soil is sandy on road crossings, the pipe will get stuck and you'll never get it out. We had a project one time, and that's the last time I ever seen moiling on a project that I was on because we wouldn't allow it. Is contractor, it was a small diameter 12-inch, and it was a road crossing out in the middle of nowhere, and instead of taking them 2 days or 1 day to put this crossing in, it took them a week because they got it stuck. So the more they hammered with the sandy soil, the tighter the pipe got, and it took them 2 D8 dozers to pull it out. So next day they took and got a permit from the county and open cut it, and they were done like the next day. So moiling is really a good method if you're doing utility work. It's my opinion. Auger boring machines. This is just kind of a definition on how you set them up, what the capabilities are. You'll see this is very common about anywhere you go is this type of boring machine. And they're very accurate. They can be very accurate on how straight they are and the depth, because you're lining it up to where your survey, where your entry and exit should be, the elevation should be the same on each side when it comes out. Slick bore method or case bore, two different methods. Like I said before, I prefer slick bore, no casing. You're basically just augering in the pipe with the right type of coating on it, and you don't have to worry about casing or casing seals. Suitable for stable, cohesive soils. Never had a problem with a slick bore. It says at the bottom a risk, higher risk of pipe damage. This depends on how the contractor's handling it, what type of coating that you have designed for the pipe. Slick bore versus a case bore. Slick bore, no casing, stable cohesive soil. Lower cost, higher risk on a slick bore, but a case bore, you have casing. Ground can be unstable and challenging if you get into rock or hard soils that are hard to auger. Cost is higher, and but the risk is lower. Choice between a slick bore and a case bore depends primarily on the ground conditions and the contractor at the time. Typically, pipeline construction, you don't tell contractors how to do their business unless it's already stipulated in the project specifications or in the contract, but it's really up to them. Engineers have to assess the soil properties, ground levels, and other factors. Contractors should be doing this also in the field when they get ready to do this work. Once again, case bore crossings tend to be more problematic with external corrosions at the casing seal and spacers. A lot of countries have an annual DOT inspection by the Department of Transportation, especially in North America, that you have to check these annually, and it becomes a problem if they're shorted out, because then you have to figure out how you're going to fix it, how you're going to shut your pipeline down and take time to fix it. I have a pullback methodology where you auger it and you pull the pipe back with the auger moving backwards. It's a technique that's not used too often, but it can be used. Example of moiling. Like I said, I'm not a big fan of moiling, but if anybody wants this information afterwards, I'm sure Rod will share it with you, but I'm not going to read it all. Horizontal directional drilling. So, like I said, this is like one of the biggest methods used in the industry and pipeline industry. Nobody knows the longest HDD ever completed because it depends on the ground conditions and the diameter of the pipe. I know some projects that I've worked on in the past, 42-inch, we did about a mile and a half of 42-inch with no problem at all. And there's other projects that have been longer than that, and a smaller diameter. I'm sure there's some longer than that here. I know in India you guys have done some extremely long HDDs also. Some examples. So the impact of the footprint of the pullback section is temporary, right? It's temporary construction. You clean it up and reseed it, replant trees, and you can't tell you were there. This is the layout for an HDD, required equipment, basically. It's a layout, and it's very minimal impact compared to other types of construction crossings. So the directional drill, start out with your pilot hole, run your pilot hole, and then you start back reaming until you get to the right pipe diameter size. Typically, the swivel attached to the reamer allows the back pull of the reamer to clean out the hole, depending on what size. 42-inch, for instance, you'll go with a 24-inch reamer, 36-inch reamer probably, and then the next size reamer, like a 40-inch or something. But this is really the method that even environmentalists like it because it's less evasive. The only thing you have to worry about is frac outs. So once the reamer's done, you're done back reaming, then you just connect to the pullback section and you pull the pipe through. So here's your pilot hole. Pre-ream, back ream. There's a picture of a barrel reamer. There's a picture of a pullback section. Whoop. And there's a bundle of pipelines pulled through a crossing. Just to give you some ideas. So eventually there'll be, I'm assuming someday in the near future or later in the future, there will be shallow water slurry pipelines eventually, because you're going to run out of space, or depending on where it's coming from, it may be easier to do it in a shallow offshore pipeline. But HDD shore approach is nothing new. They do this all the time in North America and other countries. So you can either do HDD for your shore approach instead of open cut, which people don't like on coastlines nowadays. So they're using HDD to have these shore approaches installed, and the same with microtunneling. You can also do it with microtunneling. So microtunneling is something that they're doing instead of HDDing, but it's way more expensive. Sometimes microtunnels are suited to pipelines where HDD is not feasible due to the large diameter of the pipeline to be installed, or where geotechnical conditions exclude the use of HDD, but they're way more expensive. So this is the same thing with a microtunnel approach. HDD, or a thrusting with a direct pipe, is what they're using in some offshore approaches also. They've done a lot of these in the Gulf of Mexico or Gulf of America, what do you want to call it. They're doing that now. Here's the advantages and disadvantages. Reduce the environmental impact and avoidance of culturally significant sites. There's just a lot of difference in impacts compared to from one HDD to microtunneling. Direct pipe I'm sure you guys have read about this. First crossing was done on the Rhine River in Germany in 2007. Since then, approximately 200 crossings have been completed worldwide as of 2023, so I'm assuming there's a few more. But this is the largest diameter used in this method was 56 inch, but I think right now the smallest diameter you can get down to is 30 inch. So if you want to do anything smaller than 30 inch, you have to pay the price to get the tooling made, which is really, really expensive. But it's quite the unique method. So it's specialized for special crossings where nothing else will work. So you have restricted areas. If you can HDD something like this, you might be better off HDD in it. If not, then you just keep doing what you've been doing to deal with it. I'm sure there's a possibility of HDD in this somehow if you find the right location for the pullback string and to set up the HDD layout itself. Like I mentioned, 30-inch diameters, it's its limit. Wetlands and marsh crossings. These are different types of crossing methods, but I know that some projects will have large marshlands, swamp crossings, and this is a project I managed in Louisiana. It just gives you an idea of what can be done. It may be more expensive for you. It may save you time if you're in a schedule bind, but you can get the equipment, you can get the marsh hose, you can get the barges, and you can quickly install your pipeline in marshes. This is an example of a marsh hose for a 42-inch pipeline. It certainly saved a lot of time. We dug the trench and then we used a push rack to install the pipeline. This is an example of push rack. As you can see here on the bottom, the layout. This is the back end of the pipe after it was all welded up and the floats were installed on it. I believe we was slow getting started, but we ended up maybe doing 65 joints a day at the most. But the thing about this was that we could actually get the trench in ahead of the welding, and I think the longest section we pulled was 3 miles at a time. So it went pretty quick, and it was very efficient. We used a tensioner. I worked with the contractor. They were going to use the old conventional cable pulling method to pull the pipe, but we decided that for the project, with the issues we had with the short season due to the hurricanes, that we needed to do something different. So they got an offshore tensioner, and we mounted it we put a piling in the ground. We mounted it on the pilings, and then the tensioner was used to move the pipe. After the floats run, they would continue welding and pushing the pipe out while the marsh hoe was guiding it down through the ditch. It's very cost effective. Seemed like it was, some people it seemed very expensive, but based on the other options, it was pretty reasonable. So for overview, I listed some things here. Upfront planning, site investigations, routing, geotechnical, and surveys are very critical when you're planning your project, what type of crossing methods you're going to use. The design and alignment of the site work is required. Best practices and methods included in design and the construction. So, highly recommend get your construction contractor involved in also planning these, working with you during pre-construction phase, even if the engineering is not done, or get a contractor, even if you haven't awarded the project, get a contractor involved to help you out to understand what to do. Get a good construction contractor that has experience management, good equipment, and can access the newer technology. It helps with these crossing methods. Best practices. Really what it comes down to is horizontal directional drilled methods for medium to major river crossings, the preferred methods where you can open cut some of the smaller crossings. But case crossings should only be used or utilized where there's a requirement for local jurisdiction and design requirements. Special cases and considerations for direct pipe should only be considered when nothing else works. And once again, wetlands, swamps, the push-pull rack is feasible if you have access to that equipment. You can get the equipment, but it works really well. So with that, that's just a quick overview of non-conventional crossings, and I thank you for allowing me to present this.